So today we're going to look at some basic properties of decimals. So I want you to think about something. How would you explain what a decimal was to a student that had never seen one before, similar to the question I asked you about fractions? So let's just take this decimal, 413.458. So I want you to pause the video and maybe brainstorm some ways you might talk about it, some ways you might teach it, all sorts of other things. So go ahead and pause the video and brainstorm, see what you think. Okay, so if you were going to talk about what the meaning of the 413.458, you would certainly have to discuss place value. There's no question about it. Notice the way that I said it, I didn't apply a value to it. I just read off what the numbers were. So if we have 413.458, okay, notice that time I said it a little differently, right? So we just need to figure out what the place value is. Okay, so let's do the whole number place values first. So, of course, this is the ones place. This is the tens place. This is the hundreds place. Okay, but then as we get to the decimals, we put the prefix or the suffix th on it. These are tenths. These are hundredths. These are thousandths. So our number system is base 10. So each place value is 10 times more than the place value before it. Okay, so we're going to talk a little bit more about place value. I'm just trying to introduce some of these things. We might discuss what this is in fraction form. In other words, this would be a mixed number, right? So 413.458 would be 413 wholes and then 458 out of 1,000. Pay attention to the fact that it's over 1,000, right? That's because we're in the thousandths place. We can also discuss the problem in expanded notation. Now, we discussed expanded notation in the class before this one, but we usually cover two different forms of expanded notation, so let's look at those. A is without exponents, so this would be more appropriate for like elementary age students. So we have a 4 in the hundreds place, right? So the value of the 4 in this spot is not just 4, it's 4 hundreds, right? 1 in the tens place, a 3 in the ones place, and then once you get past the decimal, we start having partial wholes, right? So we have a 4 in the 1/10 place, so it's literally a tenth, 1/10. We have a 5 in the hundredth place, and then last but not least, an 8 in the thousandth place. It's important to put that th at the end of it. But about 5th, 6th grade, we start looking at things, sorry about that, that's just a mistake, with exponents. So I already mentioned our number system is base 10, right? So this 4 would be 10 squared. The 1 would be 10 to the first. The 3 in the ones place, that can be a little challenging. How do you write 1 as a power of 10? Well, it would be 10 to the 0 power. And then we start having negative powers. Okay, negative powers mean fractions. But notice, you could have a student that may not understand all the intricacies of that, but could still figure this out, because notice the powers just go down by 1 every time. Okay, we can definitely write this number in words. And this is something that our students will be expected to do with their state testing. They'll be expected to be able to write in words what this number is. So this number would be, of course, 413. And then we use the word and to represent the decimal place. Okay, and then it would be 458 thousandths. So if you look at the fraction form, it might be easier to actually write that out. Okay. And then also, you can also introduce decimals by having students, look around their world and see some examples. Because they can certainly find some just by going, on errands to the store or to get gas or something like that. So when we talk about decimals, we can talk about money if it's just 2 decimal places. You can have them go to the grocery store. And by the way, not just talk about money, you could also have them look at like the price on the shelf. Or if you've ever paid attention at Walmart, there's a price per unit. I don't know if you've ever looked at that, but in the top corner of the price tag at Walmart, there's usually something on the aisle that shows you like how much per ounce you're paying or how much per pound or whatever. They can look at the gas pump with their mom when she's pumping gas. Okay, and for that, they could either talk about the money that was spent, right? Or they could talk about the number of gallons. They could look at the weight on a scale. Like most digital scales will give you weight to a tenth, not just whole number. So lots of different ways you could have them look around their world and find decimals. Okay, it's always good if you have them, bring in their experiences so that they can kind of relate it to things that they understand and know about. So I want you to try this one. So once I give you this number, I want you to express 23.0406124 in words as a mixed fraction and in expanded notation. And this will be a skill we'll ask of our students a lot. Here is a topic and we want you to really look at it from different angles. Okay, so I want you to do the expanded notation both with exponents and without. And it's important to note we will need to mark the zeros as placeholders. Okay, so we're not just going to skip those altogether. I would actually want you to include those. So keep that in mind. So I want you to pause the video and see if you can write out this number with words as a mixed fraction and also in expanded notation. So I'm going to start with mixed fraction. So I've got 23, and then I've got 406,124 that goes on top. Notice that 0 right there is not necessary. But for this, we would need to find out what place value we're in. So slowly, we have tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, and 10 millionths. So 10 million, there are 7 zeros in 10 million. So the reason I wrote that first is it's a lot easier to write it out in words if you already have what the fraction is. Okay, so first you write the whole number, so it's going to be 23. And now we'll write the numerator. So that is 406,000 124. So you read the numerator as is, and then you just mention what place value you're at. So we are in the 10 millionths spot. Okay, so anywhere there's an and, that indicates that that's where the decimal would begin. All right, so I'm going to move over here. We're going to need some room for this one. Okay, so expanded, both with and without exponents. So let's do without first. So every digit is going to have a value associated with it. So we'll start with the 2. It's in the tens place. We have a 3 in the ones place. We have a 0 in the tenths place. Notice I'm even going to mark zeros. We have a 4 in the hundredths place. We have a 0 in the thousandths place. So this one's kind of tedious, right? 6 in the 10,000ths place. 1 in the 100,000ths place. 2 in the millionths place. And then finally, sorry about that. Finally, a 4 in the 10 millionths place. And again, 10 million has 7 zeros. Almost ran out of room there. Let me make sure that's on screen. So with exponents, that would be 2 times 10 to the first, 3 times 10 to the 0. The ones place is always 10 to the 0 power. Okay, anything to the 0 power, in fact, is equal to 1. So that's the one that usually trips people up sometimes. We have a 0 in the 10 to the negative first spot, and then we'll just count from there. Notice that the negative exponent kind of tells you how many zeros were in the denominator. So in the end, one way we can kind of check ourselves is, do we end up at 10 to the negative 7th power, since we know the last one had 7 zeros? And it looks like we'll end up there, right? 10 to the negative 7th. So those are kind of the standard ways. We can also, I want you to get out your manipulatives. So hopefully you already have those by now. You should. So just kind of a quick reminder, and then I'm going to show you how to graph or how to draw these. This is a flat. This is a long, right? I think I already showed you how to draw these, but I'll review it again. And these are units. Okay, this is the only one that won't be in your set. Okay, I know that's a ridiculously large looking, it's just because of the angle, but it's a cube. Okay, so just to kind of remind you, remember we use this because our number system is base 10. So actually, I think maybe I haven't gone over that before. Maybe I just had you get your own set. So just to kind of recap to make sure, this is the smallest piece. Okay, this is the next smallest piece, and notice it would take 10 of these guys stacked up to be this one. Okay, and then it would take 10 of these long pieces, strips, to equal this. Okay, and then if you could see it well, this cube, which again just looks crazy big, it would take 10 of these stacked up to make the cube. Okay, so we use base 10 blocks a lot when we talk about our number system. So, but just for ease, maybe we don't always want to have out the base 10 blocks, or maybe we aren't able to have them out all the time. So we draw a cube in this way. We draw a flat just as a box, a square. We draw the long strips, those are called longs, but we don't draw them as rectangles, we just draw them as a long little unit there. And then finally the units, although they are cubes, we draw them as circles, and that's so we don't confuse them with the big cube. Okay, so if you look at your handouts that you should have printed out for the week, I want you to get out the one that says at the top, section 5.4, exploring beyond integers and fractions, decimals, exponents, and real numbers. Okay. So we're going to look at a few of these, but this is the worksheet that I want you to have out and kind of be looking at. So I want you to pause the video and see if you can kind of work through a lot of these, and then I'm just going to take just a few of them and talk about how we can use base 10 blocks to really discuss decimals and things of that nature. Okay, so pause this and try to work through this. Okay. All right, so I want to look through a couple here. So this is going to be number 1. In the middle, I'm going to call this exploration 5.14. because if you look at the middle, that's kind of what that's labeled as. All right, so number 1 says if the flat has a value of 1, represent 0.24 in 2 different ways, okay? And then justify your answers. Okay, so the first thing is we have to decide what the whole is. So let's say that we made a flat the whole. Okay, so let's just kind of recap that. Let me show that. So if the flat is a whole, that means each of these strips or longs would be 1/10, right? And because literally it takes 10 of these to line up to get the whole. And then we would call the units, those would be 1/100th, okay? Because it would literally take 100 of these guys stacked, right? So I won't do that, right? Because that would be tedious and kind of crazy, right? But it would take 100 of those guys to lay over the flat, okay? So if the flat is the whole, okay, so you do need to make sure that you say this statement right here. You have to assign what the whole is. There's 2 ways we could show 0.24. Okay, by the way, let's show this in expanded form. We have a 0 in the ones place. We have a 2 in the tenths place. And we have a 4 in the hundredths place. So if I was going to show that with pictures, I have no flats, right? I have 2 longs, and I have 4 units. Okay, notice it would be necessary for me to have said what my whole was. Okay, so an alternative way that I could show 0.24, maybe I could think of it as 24 hundredths, right? And literally we said, here's my flat again. Okay, if this is my whole, what do each of these little squares represent, right? The little units, they represent 1/100th, right? So another way I could draw this is I could have 24 of these little guys. Okay, notice I got lazy there, right? I didn't want to draw out 24 units, so I just said 24 of them, okay, in that way. Okay, so let's do number 2 on the same worksheet, 4.32 in a variety of different ways. So I'm going to switch it up on this one. So example 3, we're doing number 2 on the same worksheet. So here's number 1. If I make the flat equal to the whole, okay, then 4.32 would mean I would have 4 wholes, so 4 flats. I would have 3 tenths, right? Remember, longs would be tenths in this case. And I would have 2 units. Okay, so that's one way. Okay, notice that it says on number 2, specify your choice of unit for each representation. So let's kind of change this up. What if I instead decided to make the cube 1? Okay, so again, crazy big, right? Extreme close-up. Here's the big cube. Okay, the next smallest piece down is the flat. Okay, and then the long, and then the unit. So if the cube is the 1, then 4.32 would be 4 cubes. So to save time, I just kind of draw over and over the same pieces. Some of you are probably much better artists than me, so you can draw much prettier cubes, but good enough. Okay, and then if this is the whole, remember that would make this a tenth, right? Because literally it would take 10 of these flats to stack up, okay, to be the big cube, and then it would be 2 longs. All right, so I'm just doing some scattered questions on here. There's definitely, I definitely want you to know the concepts of everything on these worksheets. But let's look at number 6. Number 6 says, show why 0.01 times 0.01 equals 0.001 with base 10 blocks. Okay, so let's kind of recap what we're supposed to be showing. We're supposed to be showing why 0.1 times 0.1 equals 0.01. Okay, so one thing that I might find helpful is let's change these to fractions. 1/10 times 1/10, right? Both of these are tenths because the number is in the tenth spot, right? But this is not a tenth, right? Since we're in the second spot, so that would be 100th. Okay, so let's kind of talk about that. So what if your flat is a whole? Okay, so let's kind of scoot that in here. Okay, so what would 1/10 of the whole be if the flat is the whole? Okay, like what shape is it, right? What would 1/10 of that flat be? Well, it would be a long, right? Okay, so 1/10 of the whole is a long. Okay, so we'll write that in parentheses so that we don't think that's a number 1 or something. That's the picture of the long. But then if we wanted to do 1/10 of the long, it would be a unit. Okay, so in other words, we're doing another tenth. Okay, so if we do a tenth of a tenth, okay, so here is where we're going to compare the unit to the flat. Okay, so we'll visibly do this here. So here's a flat. How does this little tiny unit compare? Okay, notice that it is 1/100th, right? So in the end, the unit, which looks like this, is 1/100th of the flat, which looks like this. All right, so the last one that I want to do on this part of the worksheet at least, let's do number 7. So my intention is that you pause the video when you want to mess around with your blocks a little bit. That's what you should be doing. So for this one, we're supposed to be showing y. That means explain, by the way. Y is 0.1 equal to 0.10. And why are these also equal to 0.100? Okay, because we learned a long time with decimals, a long time ago, that we can put zeros on the end of a decimal and it doesn't change the value at all, right? So this is 1/10, by the way, right? This is 10/100ths because we're literally have 10 and we're in the hundredth spot, but this is 100,000ths. All right, so let's kind of visually with our blocks show this. So this time I'm going to make the cube the 1. The reason I'm going to want to make the cube the 1 is because I need to go all the way to thousandths. Okay. By the way, here's the big cube again. Okay. It would take literally 1,000 of these guys to equal this big cube because look at it 3D, right? So we would stack them. There would be tons of them. Okay. 1,000 to be exact. So let's talk about 0.1 first. 0.1 would be 1/10. So let's talk about what 1/10 of the cube would be. 1/10 of the cube would be 1 flat. Okay, 0.10, although equivalent, is saying something different. Okay, it's saying 10 hundredths. So think about that for a minute. If the cube, the big cube is the whole, which shape would represent hundredths? Okay, so which shape would it take 100 of them to equal 1 of the cubes? Notice those would be longs, right? So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 longs. And then last but not least, I've got 0.100, and that stands for 100,000ths. So if the cube is the whole, then the units are going to be the thousandths. So there's literally going to be 100 of these guys. So notice, we're supposed to be comparing these, right? So aren't these equivalent? Like if you were to stack up 10 strips of longs, won't that equal 1 flat? Okay, so you can physically do this probably a little better than I can show it, but you're going to compare these pictures. Maybe not the 100 units, right? Because you probably didn't make yourself that many or order that many. And notice they are all equivalent or the same size. Okay, so let's just maybe kind of practice that up here. Here's my flat, right? I don't even think I have 10 of these out, right? But if I had them, and as you're working at home, you could stack 10 of them, right, and verify that, hey, 10 of these guys equal one flat, okay? And you could do the same thing with the units, although you probably wouldn't need to do it all the way, right? But theoretically, if I wanted to take the time and I wanted to line up 100 of those units, it would be the same size as a flat. All right, so let's talk about how we can use these base 10 blocks because they're really great manipulative tools. Let me move those kind of off to the side. Let's talk about how we can add and subtract using base 10 blocks. Now, this is a topic that you should have covered in 350. Adding and subtracting decimals with base 10 blocks. You should have covered it, but maybe not. Depends on where you took 350 or 1350 is it, as it's called now. So I'm going to show you one of each and really try to pay attention to it from start to finish and make sure you could show all these details. So I want you to show 0.463 plus 0.507 using base 10 blocks as your model. All right, so first let's do the traditional addition method. Okay, so when you're adding decimals, remember you're supposed to line up the decimal, okay, and then you start from the right and you work your way left, right? So 3 plus 7 is 10, right? So we put a 0 here and we regroup the 1, okay? We try not to say carry anymore. That's not typically something you'll hear in the classroom now. 0 plus 6 is 6, right? Plus my extra 1 that I regrouped is 7. And then 5 plus 4 is 9. And your decimal place ends up in the same spot. So we already kind of know what to expect here, okay? So the first thing is, notice that we have 3 decimal places, okay? So we're going to need to let the cube be our 1. We need that because we need to be able to talk about a thousandths. We go out to the thousandths place here. Okay, so let's talk about what 0.463 would look like, okay, if this is the unit or this is the whole. So notice we have no holes, right? We have 4 flats, because those are tenths. If this is the whole, flats are tenths. We have 6 longs, because if these are the wholes, it takes 100 of these, so these are in the hundredths place. And then finally 3 units. And we're going to add that to, again, no holes, right? 0 in the whole number spot. We have 5 flats. We have no longs. Notice if we don't have longs, we just kind of skip that space, and it's my suggestion that you actually give it some space so you don't add terms that are not alike. So with a different color writing utensil, you want to try to see if we have any groups of 10. So you still start at the right and move your way left. Okay, so notice I have 10 of these guys, so I want you to actually physically show that these are going to get regrouped. So think physically, what would 10 units be? We could trade that in for 1 long. Okay, and when we do that, once we regroup, okay, then those aren't being considered anymore. So notice when we add, we get no units, so we won't draw anything for the units part. Okay, we get 1, 2, 3, 4, 5, 6, 7 of these, right? So we don't need to regroup them. We only regroup them when we have groups of 10 in our number system. And then notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we don't regroup those either. It's a little tedious to draw 9 of them. Okay, so in the end, make sure you can write out the answer. Notice we have no cubes, so it's 0. We have 9 flats, so that's in the 10th spot. We have 7 longs, and we have 0 units. Okay. So that's how we kind of show this using base 10 blocks. So I would want to see all this work. I definitely want to see your regrouping step there for sure. So if you want more practice with that, you might need to look this up online. This is a pretty mainstream topic, so you ought to be able to find adding and subtracting using base 10 blocks. So let's look at the subtraction version. So before we start, let's look at how we would do this. 1.57 minus 0.75. Just like with addition, we would make sure that our decimal is lined up. So we would start at the right and move left, right? 7 minus 5 is 2. No need for any regrouping, but notice here we have an issue, right? We can't take 7 away from 5. Okay, so we're going to regroup this whole to be 10 longs, right? So 10 of the 10th place, in other words. So that's going to become 15 there, and now 15 minus 7 is 8. Put the decimal place there. 0 take away 0 is still 0. So notice that this time I only have 2 decimal places. So you could still use the cube as your whole if you want to, but we can also say that the flat is the whole here. All right, so let's talk about what this would look like in picture form. So we have 1.57, so we have 1 whole, we have 5 tenths, we have 7 hundredths. Okay, and we're going to be subtracting off no wholes, right? 7 longs, one more, and 5 units. So if we subtract them, notice this subtracts away in pairs. So notice we have 2 units left over after we subtract the pairs. And notice here I can't take away 7 from 5, right? So just like I did before, I am going to regroup this, and notice literally visually 1 flat would equal 10 longs. And now again we can mark them off as we go. I forgot one, right? One more. So in the end we have 8. And notice we don't have any more flats, so we won't even show that at all. So we have 0 wholes, we have 8 tenths, we have 2 units. Okay, so what I want to make sure that you know is I'm really looking for you to show the regrouping. So on the homework, if I ask you to do a problem like this, then I really expect to see where you regrouped, either with the addition or with the subtraction. Okay, so let's look at maybe some ways we can use these manipulatives, or maybe just some general strategies for ranking decimals. In other words, deciding which ones are smallest versus biggest. So I've seen lots of different strategies in the classrooms regarding this topic. Okay, so one of the mainstream ones, I remember learning it this way. We won't talk about how many years ago that was. But we would line up the decimal points and compare digit by digit. So this is kind of one of the tried and true ways, okay, but I think it's perfectly fine. So let's say that I was comparing, let's do an example where we use this lineup method. So what if I asked you which is bigger? .513 or 0.51423. So one way would be to literally line up the decimals vertically like so. And you literally go digit by digit until you find a difference. So notice, same for the zeros, same for the fives, same for the ones. Notice this is the first time that the digits that are in the same spot are being compared. And of course, notice that the 4 is bigger than the 3, right? So what that tells us is the first time they were different, this one is bigger, okay? And so that tells us that 0.51423 is in fact bigger than 0.513. Okay, so if I asked you to write notes on something like this, this is what you would say. We compared digit by digit until there was a difference. And as soon as there was a difference, we determined which one was bigger. Notice we didn't go to the end of the decimal. We didn't need to. Okay, we just go until we see a difference. So that's one strategy, certainly for comparing decimals. Okay, so let's look at another. You can also change to mixed fractions. The key here is you have to be comparing apples to apples. You have to be comparing things with common denominators. And by the way, in your classroom, you would introduce decimals after fractions. So they already would be, aware of the fact that a lot of times we need common denominators. So let's talk about what 0.513 is as a decimal. Okay, notice we don't really have a mixed fraction truly because we don't have a whole number component, but we have 513, and then if you do tenths, hundreds, thousandths, we're in the thousandths place. Okay, so this would be 513 thousandths. Okay, so let's leave that alone for a bit. We'll probably come back to it. What about this one? This would be 51,423 tenths, hundredths, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So this would be 100 thousandths. Notice right now my denominators are certainly not the same. This is 1,000, this is 100,000. So for this we would need to get a common denominator. So I'm going to multiply top and bottom by 100. Okay, I'm allowed to do that because it's just like multiplying by 1. So in the end I get 51,300 100 thousandths compared to, I didn't really change this one, 51,423 100 thousandths. Okay, so which one is bigger? This is 51,300, this is 51,423. Okay, notice that when we get the denominators the same, we don't need to worry about the denominator anymore, we just need to compare the numerators. Okay, so now that the denominators are the same, so it's very important if you're going to use this method that you make the denominators equal. So since the denominators are the same, we just compare the numerators. Okay, so again, we aren't surprised to get the same answer, right? So 0.51423 is again bigger than 0.513. But the real reason we were able to say this is because 51,423 is definitely bigger than 51,300. Okay, so we were just comparing numerators alone. For smaller, more manageable numbers, you can also use base 10 blocks. So we would not use base 10 blocks for a number like this, probably. Okay, mainly this one is the problem because there's 5 decimals. We don't really have enough blocks for that to work. In other words, we don't have enough sizes. We only really can do 3 decimal places nicely. We can technically go more, but it's complicated. So let me ask you a different question. Which is bigger, 1.7 or 1.639? Okay, now hopefully we know the answer to that. Okay, but how would you teach this? Okay, so notice we're comparing something with 3 decimal places. So just like I mentioned earlier, you always need to state when you're using base 10 blocks what your whole is going to be. So notice 1.7, okay, would be 1 whole unit and 7 flats. Whereas 1.639 would be 1 cube, right, 1 whole, 6 flats, 3 longs, and then 9 units. So notice it's kind of like a digit by digit comparison. These are the same as each other, so we're good there. These are the same. You basically compare until you hit a snag, until you hit something that is different. Okay, so now notice what's left. We have this left, and we're going to compare it to the left over here. So you're really asking yourself which is bigger, which is more, a flat or 3 longs and 9 units. Okay, notice a flat would actually be 100 units, right? So clearly bigger. So the strategy is compare piece by piece until you find differences. So if you physically looked at the blocks, notice that this is certainly bigger than this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 more. So in the end, make sure you say the answer right. 1.7 is greater than 1.639. So the last way, and again, kind of like the base 10 blocks, you probably wouldn't use this method unless you had more manageable, smaller decimals. Okay, so let's say I asked you which is bigger. And let's say, let's just stick with the 1.7 or the 1.639. This will be a good practice of knowing our decimals. So both of these numbers are in between 1 and 2. So notice in the middle we have 1.5, right? So if we list all the decimals in between 1 and 2, and then we're just going to plot what these numbers are. So notice 1.7 would be about right here, whereas 1.639 is closer to 1.6, so maybe about right here. So you'd want to choose a scale appropriate for what you have, and notice values on the right are bigger as they are on all number lines. So with the handout that I uploaded on D2L, you need to practice kind of all of these methods, okay, all 4 that we just mentioned.